Hello there. Hope you are doing well. Welcome to the course on GD&T. The course is actually designed for engineering students, graduates, or industrial professionals who are having a background in mechanical, production, industrial, or operations engineering. The topic for the day is GD&T. The full form of that is geometrical dimensioning and tolerances. You must have seen these types of drawings. As you can see, these types of drawing you must have seen somewhere. These are actually the GD&T, the geometrical dimensioning and tolerances. GD&T is one of the most important topic in the life of an industrial professional, a working professional, or a student fresher who is actually looking to begin his or her career in industries, especially I would say the mechanical industries, the industries which are related with the mechanical work, with the machines, with the drawings and all. At any point of time you will have to go through many of the theoretical things, and out of those theoretical things, GD&T is one of them. GD&T will also help you in interviews. The knowledge of GD&T is actually required because if you will appear for any of the interview, definitely if it is related with any production work, any manufacturing work, there is some involvement of designing, drawing, CAD work, definitely this GD&T will come up. And there are many questions asked on this. Even in many of the competitive exams, the questions are asked on the same, the GD&T. In this course, we will be covering everything from the sketch. We will start it from what GD&T is, where it is used, why it is used, and from where it actually has been started. We will also be exploring GD&T, how much this particular thing, this GD&T is helpful and useful to you in your career, and where exactly you will be able to utilize it, how it will help you in interviews, how it will help you in cracking the competitive exams, how it will help you in creating the designs, creating the CAD models, creating the engineering drawing. Even it helps you in reading the drawings as well, because without that it will be very much difficult for you to read the drawing. Definitely, to create the drawing, that will also be a difficult case. So this is what GD&T is, and that we are going to cover. Now, before starting anything about the GD&T, I would like to ask some questions. I would like to start from some questions. The the first ever question that comes to mind is, first, are you from the mechanical engineering background, or from the production engineering, or any industrial engineering, automobile engineering, aerospace? Again, it doesn't matter whether you are a student or working professional, whether you are graduate or you are pursuing your degree, it doesn't matter. The thing that matter is, are you from the mechanical, from the production, from the industrial engineering, automobile engineering, aerospace engineering background? Again, are you a part of a team in an organization? Are you a team member from any organization who actually deal with this? or are you preparing for any competitive exam related to these things, the mechanical, production, industrial, automobile, aerospace, engineering background? If yes, then definitely you must have seen this. Think about it. Have you seen these things before? If you have not, and if you are from the same streams, then definitely in your career you will someday, somehow, you will see that. There are some curves, there are some lines available, uh, there are some symbols available, there are some figures, some dimensions, some numbers, some tables. There are many things in this. If you'll focus on this, there are so many numbers, lines, curves, some symbols are there, some tables are there, something is written somewhere, some symbols are placed. There are many things. What these things are? What is that? What you call this particular thing? The thing is, from this, we will go to the GD&T. But before going for the GD&T, we will need to understand what this thing is. So, a simple answer to the simplest question ever, this particular thing is actually your engineering drawing. This is your engineering drawing. Some will call it as the drafting, some will call it the production drawing. It can be called somewhere as the inspection drawing or assembly drawing. Different drawings have different names, but commonly, yes, we call it as engineering drawing. Now, what engineering drawing is, we'll need to understand that first. The basic. The engineering drawing is actually a language of communication from one end to another. Via engineering drawing, what exactly you are doing? You are communicating something. It is a language of communication. It is a way of communication of information from one end to another end. The one end can be the designer, another end can be the user. So it is a language of communication from the designer to the user. Now, what can be the user? Who actually is the user? So user can be the operation people, the machine operator who is actually using that drawing to manufacture the desired part. It can be the inspection team member who is actually inspecting the particular part. It can be the assembly team member who is actually going for the assembly of the particular machine. It can be the production manager. It can be even the customer. You must have seen, whenever you purchase something, you must have seen there is a booklet available with whatever you purchase. There is a booklet available, and in that booklet there are some processes, there are some procedures given about how to use that particular part, how to use that particular thing, how to assemble that, how to deassemble that if required. Let's say if we'll talk about the TV remote, what happens? There is a booklet available in which they show you how you can insert the batteries, how you can insert the cell in the TV remote. There are wireless things available, let's say wireless mouse, wireless keyboards. If you will purchase it, there will be a booklet available which will show you where exactly that Bluetooth device is in the mouse itself, how you can put in the battery or the cell in that mouse, how you can turn it on, turn it off. What is that? That is actually a drawing. That is actually an engineering drawing, which is communicating something, which is communicating the idea of the designer. about how to use that. It is actually communicating what designer had thought while designing the particular part, that this is how the user will use it, this is how we have to utilize it, this is how this particular part will satisfy the need of its customers. So that's all come under the engineering drawing. And what exactly it is doing, it is actually communicating the information. And this thing will help you in the interviews, because majority of questions comes from the engineering drawing. And this GD&T is actually a part of engineering drawing, because there are so many things included which we will discuss now. So you must be wondering what exactly these things include, what exactly the engineering drawing includes, what are the things we'll need to mention when we say it is an engineering drawing. What are the necessary things which makes it an engineering drawing? As we have discussed, we had some lines, we had some curves, circles, dimensions, symbols, information. There are many things. So let's elaborate what exactly engineering drawing includes. So the engineering drawing includes the information, as we had already told you that what it does, it communicates the idea, it communicates the information. So definitely it will have the information. The information will be about views. In the engineering drawing, you will find some typical views like orthographic views, like isometric views, some section views, detailed view, just to represent your 3D object into 2D. Then there will be some dimensions. Again, dimensions will be applied on the views to represent the size of your object, because it is very much difficult and critical to apply the dimensions on 3D, because you will not be able to get the exact values. So what we do, we apply the dimensions to represent the size of the object in 2D on the views. Then we will have some notes, some information text will be available. We will have some tables if required, just to list it down. Let's say if an assembly is there, then I will need to give a table having details of all the parts. If a particular part having so many holes are there, then I'll need to represent the whole table. So there will be tables available. There will be different symbols representing, say, welding operation, say machining operation somewhere, to maintain some specific roughness. Then there will be symbol mentioned on in the engineering drawing. And finally there will be dimension and geometrical tolerances. There will be dimensional and geometrical tolerances. And definitely during this course our focus will be on this only. So starting with the tolerances only. First we will elaborate the tolerances, what exactly it is. Then we will shift on to the specific case. So the tolerances are actually allowances for a specific variation in the size and the geometry of a particular part of or a product. There is a need to apply tolerances whenever you go for engineering drawing, whenever you go for the drafting. There is a need to apply the tolerances, because you cannot get the perfectness. There is nothing perfect. Means you will not be able to achieve the accuracy. When you will not be able to achieve the accuracy, then you will need to give some relaxation or some allowances, that is called the tolerances. We try to go close to the ideal case. We try to go close to the perfection. Definitely, we cannot achieve it, but we try to be as close as possible. The tolerances should also not be more. It should not be more. The value should not be large, because large variation may create the problem in functioning of the part or assembly. Again, it should not be very much small, otherwise it will affect the cost. Because if you will try to achieve the perfectness, then you will need to spend more money, because there will be large number of rejection. So that also we will need to keep in mind. We need to decide, we will need to take the decision for the tolerances, which requires precise manufacturing and requires inspections and rejection of parts. We have to control that. There should not be huge number of rejection in the parts. Second thing, it should be inspectable. If we are unable to inspect the part in that much of precision, then there is no point. We have some inspection devices, we have some tools available, equipments available having least count say 0.0001, and if we have given the tolerances of 0.00001, then we will not be able to measure it. When we will not be able to measure it, there is no point in giving that variation or giving that tolerances. So we have to keep that as well in mind, because whatever the tolerances we have given, first, whether it is possible to achieve for us, do we have that much effective machines available? Second, is it possible to inspect that? And third, if it is possible to inspect, then we will think about the rejection. So this is what tolerances are. Then why it is needed? Why we need the tolerances? There should be some reason because of which the tolerance thing comes into mind. One of the reason is assembly. Assembly can be a reason, because normally when you go for the parts, when you go for the assembling of parts, the parts will not fit in each other if you have not given the tolerances. So if their dimensions do not fall within a certain range of values, it will be difficult for us to assemble the parts. We need to give the range, we need to decide the range for that, and that range is actually your limits, that range is actually your tolerances, we can say. Another reason can be interchangeability. We work with the batch production. We are not actually working for a single part. What we are doing is we are working for the batch production. And definitely, if a particular part is there for the batch production, you cannot achieve the same dimensions for each and every part. What we want is the part should be interchangeable. Let's say if a particular part is not getting fitted, then I'll try another part and it should get fit in that. So for the interchangeability as well, we'll need to keep that range. Many times we use the replacement. In case of any breakdown, we need the replacement of a particular part. And if that replacement part is not up to the mark, then there is no point in using that. So we have to design in such a manner that we can interchange it with some other replacement part. And also, to maintain the relationship between functionality and size or shape of an object, which varies from part to part. For this, we need the tolerances. These three are the main reasons to use tolerances in the engineering drawing or the drafting. Then, what are the types we have for the tolerances? How we can categorize the tolerances? So, there are two types of tolerances we have in the engineering drawing. One is dimensional tolerances, another one is geometrical tolerance. Dimensional tolerances actually works for size of an object. We can say dimensional tolerances maintains or controls the size of the object. There are three different ways to apply dimensional tolerances. One of the way is your limit tolerances. So as you can see, this is how we apply the limit tolerances. What we give is we give the upper as well as lower limit value of the dimension. If the actual value of the manufactured part lies within this range, then the part is accepted, otherwise it will be rejected. This is how we apply the limit tolerances. Another way is unilateral tolerances. So in case of unilateral tolerances, one of the limit value will be same as nominal size. So as you can see, there is 0.0000 and another value is 0.0005. One of the value, one of the deviation will be 0. It will be same as the nominal value of your particular feature. And the third way of applying dimensional tolerances is your bilateral tolerances. In this case, we will be giving different values to both upper and lower deviation. The value can be same or different, but yes, the values will be on both the deviation. There will be some upper value, there will be some lower value to the deviation. I hope you are clear with this, the different types of dimensional tolerances, the limit tolerances, unilateral and bilateral dimensional tolerances. Then comes the another type of tolerances, which is the geometrical tolerances, the topic for the day. It actually works for shape of the object. Our major focus will be on that only. We will be applying the geometrical tolerances for managing, for controlling the shape of the feature. These shapes are like, say, cylindrical shape, the circular shape, flatness, we can say the perpendicularity. We will be discussing these shapes in detail during this course, how we can apply, where we can apply, what we should apply. And this is how one geometrical tolerance can be applied. You can see there is a hole of 35.2 diameter, and there is one frame, there is one geometrical tolerance applied on that. We will understand the meaning of that as well. That particular thing is actually your feature control frame, which maintains, which controls, which manages the complete information about that geometry, its dimension, and its tolerances along with the references as well. So, so far we had discussed the background about the drawing and tolerances. Now let's focus on the GD&T. So the full form of GD&T is geometrical dimensioning and tolerances, as we had discussed. It is an international language used on drawings to accurately describe a part. As we discussed, it is a way of communication, it is a language of communication just to transmit the information, just to convey the message, whatever we can say. And the thing is, it is a drawing, it is a set of symbols which we place in our drawings to describe the details about the particular part. As we discussed, it consists of well defined set of symbols, rules, definitions, and conventions. And these set of symbols, rules, definitions, and conventions are required to be known to you, because these are the things which are actually asked in the interviews, which are actually asked by people who are actually working in the industries, and they prefer this knowledge to be there, because this is what you have to work on. If you know it, definitely you will be preferred for the particular position you are going for the interview. So this is just the basic. The everything in detail will be covered throughout the course. Once the designer mention these things in the drawing, he or she does not need to go to any particular person and explain anything. What happens is everything is being communicated via these things only. You don't need to go to the particular person and ask, or uh, tell that person anything. No, everything is there. You don't need to write anything. You don't need to specifically uh, tell anyone that this is what required to be done, or follow this particular process. No, nothing. Everything is automatically being communicated. Even this GD&T thing covers your manufacturing process, how you have to manufacture the particular part, inspection process, and sometimes yes, it does follow the, or it does describe the assembly process as well. Then let's go back to the history where exactly the GD&T has started, from where it has started. So we'll go back to the history. We'll just have a brief about history of GD&T. So history of GD&T goes back to Second World War, when there was shortage of ammunitions, and they started using similar products as the replacement to their parts, because everything was down, and yes, there were requirements of almost everything. So what they had done, they had started working with a similar kind of product. I cannot say it was a proper replacement, but it was a similar product they used as a replacement. And this particular thing has given the birth to a term called as interchangeability, and a high volume productivity, or I can say a high volume of production has been started of the Liberty ships, aircrafts, and ground vehicles. Thus, interchangeability was used, or the advantage of this interchangeability was taken by automotive industries, It was the advantage was taken by computer industries. They built their hard disks. Again, it was a similar product. We cannot say that was the original one, but it was similar. You can do your work with that. Engineering and scientific methodologies, those things are also developed. And thus, GD&T or the interchangeability has become a hot topic for the research after that. Once you start using something globally, then it is must necessary to standardize that particular thing, because you are using it globally. If it is not same for all, then it will create problem for all. So for the same, the American National Standard Institute, known as ANSI publication, has done some work. They published the standardization of GD&T in 1982 with the name ANSI Y 14.5M, year 1982. They had given the first standardization of GD&T, and after that GD&T was globally adopted and used by the industries, and more research has been started. After that, yes, ANSI has released so many versions of that particular note. There are updated versions. There were so much development after that, and the same development is recently released, the newest version of that, which we will be covering. So this was the history of GD&T, from where exactly it has started, and how it has been adopted. Then comes why. What exactly is the reason of adopting? Why exactly we have to work or we have to use GD&T? For you, if you will think to get the job, a simple thing I can say. But again, you, if you want to clear any competitive exam, you want to appear for the interview, you want to crack the interview, then yes, for you, this is the thing, you need the GD&T. But why industries need the GD&T? Why they had adopted the GD&T? Why we have to apply the tolerances to this? The reason can be because GD&T is a way of dimensioning that takes into account function and fit with related part. Whenever you apply the GD&T, it covers both the things. It's functioning as well as the fitment. Both the things it covers. That's why it is most required. Another reason of that can be that the part cannot be made exactly according to the drawings. Definitely you cannot go for the production with the 100% accuracy. You cannot achieve that. It is quite impossible during your manufacturing or development stage. When it is impossible, definitely you will need to give it. GD&T also allows drawing to be more accurately dimensioned with looser tolerances. This method of tolerancing actually reduces the rejection of parts in the industries, and that rejection of part is directly related with the cost of the product. So if this process is actually saving your cost, then definitely the industries will adopt it. Otherwise, they would not have adopted the process or the methodology. And then finally comes the advantages. Advantages of GD&T. Why industries had adopted, and what exactly they are getting out of it. So the most important advantage of GD&T is that it is a standardized methodology and international system. It is universally accepted and understood. The standardized process is there. It is not like I had developed, only I can understand. No, it is universally understood. If I am using it, if the other person, this, let's say the client is using it, if I have mentioned something using this standard, the person will be able to understand that. And this is what I need. This is what I wanted to communicate. My communication is done. Yes, industries will accept it. Another advantage, it is a clear technique for defining a reference coordinate system. Normally we call it as datum in the technical term, on a component of or assembly. A reference which will be same for all the operations performed on the part, whether it is manufacturing, whether it is inspection or assembly. Whenever you work in the industry, for a, say, let's say I'm working for a single part as a designer, then I'll need to make sure that I choose the datum, the reference in such a manner that that particular datum will be used for all the operation going to happen on that particular part, whether it is manufacturing, whether it is, let's say, the inspection, whether it is assembly. Everything should be with respect to the same datum. Then and then only you can assure the quality of the product, otherwise you cannot. The GD&T method is actually more flexible as compared to the traditional dimensioning tolerances system. This flexibility actually helps you while working with the complex shapes. Another advantage of GD&T is the GD&T method reduces use of notes. You don't need to write anything other than these symbols. You must have seen the so many written text in your drawing sheets earlier, and when you are writing so many things, it looks messy. So to reduce that, we started using the GD&T symbols, and in that feature control frame, the GD&T symbol, all that written notes of 4 lines, 5 lines has compressed to a single, say, frame or a symbol, which explains the same thing. You don't need to write it. You are explaining it, or you are communicating the same thing via a particular symbol which comes under GD&T. And the methodology is actually based on fit and function both. You cannot use this for only fit or only function. It will go with both. It will work with both. While applying GD&T, we focus on both the fitment as well as the functioning of part or the assembly. So this was all about the GD&T, where we can use it, how we can use it, when we can use it. Definitely you all will be using the GD&T once you're done with this, and at a certain point of time, definitely you are going to utilize this. So this was all about the GD&T. Now let us come down to the table of content for the course, what we had included. So we'll be starting with the first thing, that is the introduction. The introduction will be related to the terminology of GD&T, the symbols, what are the symbols we have, their meaning, their uses, their application, etc. Then we will be covering the features and rules of GD&T. Actually, the GD&T is applied on the features of part or assembly, that we are going to discuss in detail. There are some thumb rules of GD&T. We will discuss that as well. in this particular course. Then we will be going for the datums, datum control, the references as we discussed. We we will be applying using all the datums. Different datums will be there for different GD&T features. We will also discuss how we can select the datum, because that is also a necessary part, as we had covered that it is important to select a datum which will be same for all the operations. So that decision is also in the designer's hand, that also we have to cover. Then how to apply, where to apply the GD&T, whether wherever we are applying, whether it is applicable or not, that also we have to check. Then finally we will be going for the GD&T characteristic symbols. There are 14 characteristic symbols in the GD&T divided into different categories. We will see those categories as well as the symbols. These categories are: first, form tolerances, in that straightness, flatness, circularity, and cylindricity is included. Then comes the orientation. Orientation are parallelism, perpendicularity, and angularity. Then we have profile control, profile of a line, profile of a surface. Then we have location control, position, concentricity, and symmetricness. And finally, we have the runout tolerances, which we will be applying circular runout and total runout. So this was all about the introductory session related to your GD&T, how we have to use it, where we have to use it, what exactly the history of GD&T is, where it is used, why it is used, and what are the things we are going to cover. And the most importantly, how it is going to help you, because it is important for you to understand why you are going to join this, why you want to learn this. Otherwise, there is no use to this. If you are not aware what to do after completing this, then there is no point in doing this. So, this was the introduction to that. You can utilize the same knowledge for interview cracking. A simple rectangle having some holes, the interviewer can draw, and he or she can ask you, apply GD&T on this. If you have knowledge, then you will be able to continue further. Otherwise, it will be difficult. In the competitive exams as well, there are questions asked on the datums, there are questions asked on the applicability, there are questions asked on the symbols. What is the meaning of that symbol? What is the meaning of this symbols? So all these things we will be covering in this particular course. That's it from my side. I hope you are clear with this. Thank you.